morning. Myself, V.S. Pavan Kumar, Associate Professor from Department of AIML, MLR IT. In continuation of Computer Network subject, today we are going to discuss about the topic transmission modes and network hardware and software. So let's start with transmission modes. So, what is a transmission mode? The way in which data is transmitted from one device to another device is known as transmission mode. Transmission mode is also known as the communication mode. So, how you are going to communicate? In what way you are going to communicate? So, if you want to transmit the data from one system to another system or from one device to another device, how that particular data is being transmitted, the way that you are transmitting is nothing but a transmission mode. So, each communication channel has a direction associated with it, and transmission media provide the direction. Therefore, the transmission medium is also known as directional mode. So, whatever the direction that you've been following, so the way in which the direction is being guided, so based on that particular guided direction, the transmission of data takes place from one system to another system. So, therefore, this particular transmission medium is also known as directional mode. The transmission mode is defined in the physical layer. So what is this particular physical layer? Already we had a discussion regarding this particular physical layer. So this is the 0th layer or the first layer of this particular OSM model. So usually in this particular physical layer, the data will be transmitted in the form of bits, zeros and ones. So this particular transmission mode, whatever the mode that you've been using for transmission of the data from one system to another system or from one device to another device, the data will be transmitted in the form of zeros and ones in this particular physical layer. So that particular will be defined in this particular physical layer. So actually, coming to this particular actual discussion regarding this particular transmission modes, we have three modes of transmissions. One is simplex mode, and the other one is half duplex mode, and the third one is full duplex mode. So these are the modes of transmissions we are being using for transmission of data from one system to another system. So coming to the discussion regarding this particular simplex mode. So the name itself indicates the simplex mode in the sense the data will be transmitted only in one direction. So the data transmission in one direction in the sense, so the transmission in only one direction. That is, either the data will be transmitted, say for example, if you consider this particular system A and this is system B. So either the data will be transmitted from system A to system B, or the data will be transmitted from system B to system A. Only one at a time, but not at the same time. So that we call it as a simplex mode of communication. So if you consider this particular example, the example for this particular transmission mode, that is the simplex transmission mode, is keyboard or mouse. Keyboard or mouse. So with the help of this particular keyboard, you can able to enter the data into the system, or with the help of the clicking of the mouse, the data can be entered, or you can be selecting a particular data in this particular system. So that is the best example for simplex mode is keyboard or mouse. Half duplex mode. Second way of transmission of the data is half duplex mode. In this particular half duplex mode, the data will be transmitted in either directions but not at the same time, simultaneous. What here is transmission in either direction but not simultaneously. So transmission in either direction, that means either the data can be transmitted, for example, if we consider A as one system and B as another system. A, the data will from system A to system B or from system B to system A. The data will be transmitted only in one direction but not at the same time. So the best example for this particular half duplex communication is walkie-talkie. So I think you all know about this particular walkie-talkie. There will be two persons speaking with some particular physical device. So say for example, those are the two persons A and B. A starts speaking and B should listen until the A communication is being completed. Once A communication is being completed, he will be specifying that the data which is being once the data has been completely done, he will tell that the data is over. After that, B starts replying for that particular data. So that means the data will be transmitted in both directions but not at the same time. Whereas in this particular simplex mode, the data will be transmitted in only one direction, that is from A to B. For example, if you want to transmit from B to A, it is not possible. So in simplex mode of communication, the data will be transmitted in only one direction, whereas in the half duplex mode, the data will be transmitted in both the directions but not at the same time. It is just like one more example. This is one of the examples, walkie-talkie. Another example is if you take in real-time scenarios, one-way traffic. So one-way traffic in the sense there is only one road, and once if you have been transmitting the traffic in one direction, after that the opposite directions vehicles will come. So that is the best example for the half duplex mode of communication. And coming to this particular full duplex mode of communication. Full duplex in the sense transmission will be done in both the directions and at the same time. That is, for example, if you consider the system A and system B, so you can transmit the data from system A to system B as well as system B to system A simultaneously. So the best example if you take for this particular full duplex mode of communication is telephone. Telephone is the best example for this particular full duplex mode of transmission. So in this particular telephonic transmission, what happens? Both the persons start communicating at the same time, and at the same time both of the communicating parties will be able to listen both the communicating information, and as well as both can convey the information at the same time parallelly without waiting for other particular person. So that mode of communication we call it as a full duplex mode of communication. So if you want to transmit the data from one system to another system, these are one of the transmission modes that we have been using, that is half duplex, simplex mode, half duplex mode and full duplex mode. So these are the ways that you are going to communicate, and as we have been specifying the directions, so this particular transmission mode is also known as directional modes. So this is about the transmission modes. I think it is very much clear about all the transmission modes. So I have clearly explained you regarding each and every mode, and I have clearly given you the examples for each and every thing. And coming to the discussion regarding this particular network hardware. So what is this particular network hardware? Network hardware is a set of components or hardware required to form a network. So set of components. If you want to facilitate the communication, we require the components. So without the help of communication, without the help of components, the communication is not at all possible. So the group of components or the hardware required, the hardware is nothing but the physical equipment. So we require a physical data, we require a physical devices. So to establish a communication or to arrange the communication or to facilitate the communication, so that particular hardware or the set of components required to form a network. So these particular set of components will be combined to form a network. That is nothing but a hardware. For what purpose we are using this particular components, or for what purpose we are using this particular communicating components? So these are essential for interaction and communication between hardware units operational on a computer networks. So if you want to facilitate the communication between any two components physically existing, these particular components are required for interaction among those particular hardware devices. So the best examples of the network hardware includes hub, switch, bridge, repeater, router and gateway. These are the 6 network hardware components required for transmission or interaction between the hardware units in the computer network. So coming to the discussion regarding this particular hub. Hub, it is used to transmit the data packets to all the connected devices. So for example, so here we have a centralized device. So I am calling it as an hub. Here we have systems. This is system A. This is another system B. System C. System D. Say for example A, B, C, D. Right? So this is a centralized device called as a hub. So if you want to, if the data is being received to this particular hub, if you got the data to this particular hub, what this particular hub does is that, what it does is that it transmits the data to A, B, C and D. So it is going to transmit the data in the form of packets. So the data transmission will be taking place in the form of packets. So that is what it is used to transmit the data packets to all the connected devices. What are the connecting devices here? A is one of the connecting device, B is another connecting device, C is another connecting device, and D is another connecting device. So all the 4 devices have been connected to this particular centralized device called hub, and this particular hub will transmit the data in the form of packets to all those particular 4 devices, right? It doesn't have any filtering options. So irrespective of this particular address, so for example, actually the transmission require only for particular D device, but what this particular hub do, it will not consider any kind of the data, any kind of address, and simply whatever the connecting devices that are connected to that particular hub will be transmitted to all the connecting devices. So for example, say for example, if the actual address is to particular D, so what happens here? So whenever the particular data is being transmitted by the hub to A, what it do? A will check the address and it will cross verify with its address. If matches, if both of them matches, it is going to take that particular address. If mismatch occurs, it is going to discard that particular data. In the same way B, in the same way C. Whenever the data reaches to D, it compares the address with the receiving address. As both of them gets matches, as actual destination is D, so what happens? It will accept that particular data. So rest all the 3 ABC devices will discard this particular data. So this is how the data transmission takes place in this particular router, that is a hub, which is one of the components of the network hardware. And coming to this particular switch. So before going to switch, I'll have a discussion regarding this particular repeater. So what is repeater? A repeater is used to regenerate the signals to maintain the signal strength. So whenever the data is being transmitting from one particular device to another particular device, what will happen? The signal strength decreases based upon the network. So either the signal strength might increase or signal strength might decrease. So what happens? In order to increase the signal strength or to regenerate the signal strength, we use this particular repeater. So all these particular networking devices must operate in any one of the layers in the OSA model. So we have 7 layers in the OSA model, like physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So this particular repeater works in this particular physical layer. So the main purpose of this particular repeater is to regenerate the signal. Whenever the signal strength gets reduced, to compensate that particular one, we use a network hardware device called repeaters. Now coming to the discussion regarding this particular switch. So what is switch? It is similar to repeater. So whatever we have discussed, so whatever the functionality that the repeater is having, the same functionality will be given to this particular switch. That means the regeneration of the signals. Now it is similar to repeater with some additional functionality. So if both of them are same, why do we require switch then? So to overcome that particular problem, we have some additional functionality in this particular switch. What is that particular additional functionality? Is that in this, error checking will be done. So error checking will not be done in the repeater, whereas this particular switch, error checking will be done. So what is this particular error checking mechanism? That is, the good data packets will be sent to the correct ports. Good data packets will be sent to the correct ports. Good data packets in the sense, the packets which are having the signal strength good. So that means the data packets with errors will be ignored. So the packets, whenever a particular data in the form of packets reaches to a switch takes place, switch have a filtering capacity. So it will check whether this particular packet is free from errors or not. If it is free from errors, it is going to forward that particular data in the form of packets. If it is not free from errors, so simply it will discard that particular packets. So that particular additional functionality is being included in this particular switch, which is one of the networking hardware devices. That particular functionality, so whatever the filtering functionality that is being included in the switch will not be included in the repeater. This is one of the disadvantages of the repeater. So to overcome this particular repeater problem, we have used this particular network hardware called switch. And coming to this particular bridge, this is another networking hardware. So what is this particular bridge? Bridge, it is used to interconnect two different local area networks, LANs in the sense local area network. So this particular bridge, it is used to interconnect two different LANs. So this is one LAN, so this is one other LAN. It is going to connect two different LANs working on the same protocol. So this particular, say for example, this is LAN 1 and this is LAN 2. LAN 1 and LAN 2. So for example, this is LAN 1 and this is LAN 2. Both the LANs are working in the same protocol. So for example, this particular LAN is working on TCP/IP and this particular LAN is also working on this TCP/IP. So each and every local area network will follow some of the rules and regulations specified by the protocol, right? So in bridge, this particular bridge, it is used to connect two different LANs. So these are the two different LANs working on the same protocol. So the protocol of LAN 1 is TCP/IP and LAN 2 is also TCP/IP based on the MAC address. So we'll have a MAC address. Based on that particular MAC address, it is used to interconnect two different LANs working on the same protocol. And this particular bridge works in data link layer. It works in data link layer. This is about bridge. And coming to this particular router, what is this particular router? Usually in router, the data will be transmitted in the form of packets, right? Packets will be routed to destinations using the best routing paths. Say for example, you are from particular source. Say for example, you want to travel from Hyderabad to Vijayawada. Say for example, you will have n number of paths to reach to Vijayawada, right? So the destination is the source is Hyderabad, source Hyderabad, destination Vijayawada, right? So you have n number of paths to reach from Hyderabad to Vijayawada, but you are supposed to select the best route path where there will be no congestion, where there will be no traffic problem. Traffic problem should not be there, and the minimum distance, a minimum time, shortest distance, shortest time. So that is how. That means you need to select the best path out of all the paths. In the same way, the router, if it wants to route the data in the form of packets, the packets will be travel to the destination in different paths by taking different time, out of which the router must select the best path to reach to the destination. How router is going to select the best path? Here the router will employ different kinds of routing algorithms. We have n number of routing algorithms like adaptive routing algorithms, non-adaptive routing algorithms. So in that we'll have some shortest path routing algorithm, Dijkstra routing algorithm. So we'll have n number of routing algorithms. So those with the help of that particular routing algorithms, it is going to select the best path to travel the packets from source to destination. Next, routing will be done dynamically, so not statically. It can be adaptive in nature. So it dynamically the route can be identified based on the requirement of that particular router. And this particular routing router will work in network layer. So usually in network layer, the data will be transmitted in the form of packets. So here the packets transmission takes place in the router. So this is one of the networking hardware component, one of the examples of the networking hardware devices. And the last one is gateway. So what is this particular gateway? It passes the data from one network to another network, which are operating in different protocols. Coming to this particular, if you take this particular bridge, both of them works in the same protocol, but whereas in this particular gateway, it operates in different protocols. For example, this is one particular gateway, this is another particular gateway. Say for example, Z1, Z2 is two different gateways, other networks which are operating in two different protocols. For example, it is working in TCP/IP, so this may be working OSI. So these two gateways are being employing in two different protocols. It is also called as protocol converter. So actually what happens here, so the TCP/IP will have one kind of mechanism, OSI protocol will have some kind of mechanism. So both of them are not matched. So what it is do, this particular gateway will provide some kind of conversions from either from OSI to TCP/IP or from TCP/IP to OSI. So anything can be happen, right? So this particular gateway is responsible as a protocol converter. So either it can be converted to this or this. Anything can be happen. So these are the different network hardware components or network hardware devices which are mainly responsible to facilitate the interaction and communication between the hardware units. So whenever a communication is being required, not only the software, hardware also plays a vital role. So because with the help of these particular components, physically transmission of the data, this particular network hardware is important. Next topic in continuation of the network hardware is network software. So what is this particular network software? So what is a software? You know, software is nothing but a set of instructions. And in this particular network software, we have the protocol hierarchy. So protocol hierarchy, in the sense, protocol means, what do you mean by protocol? Set of rules and regulations. Protocol, in the sense, set of rules and regulations. So in this particular network software, we have n number of topics like protocol hierarchy, design issues of network layer. So we have n number of topics. In the first one, as of now, I am going to discuss about this particular protocol hierarchy. What is this particular protocol hierarchy? See clearly, here we have two different hosts, host 1 and host 2. Host 1 can be a client or server or sender. In the same way, host 2 also, it can be a client or server or sender. So for example, if host 1 is a client, host 2 will be considered as a server. If host 2 is considered as a client, host 2 will be considered as a server. Or if host 1 is a sender, the host 2 will be the receiver. Or if the host 2 is a sender, host 1 will be the receiver. So here we have this particular protocol hierarchy is employed in 5 layers. It is being worked in the 5 layers like layer 1, layer 2, layer 3, layer 4, layer 5. Like application layer, presentation layer, network layer, data link layer, physical layer. Right? We have different layers. So leave about the names of that particular layers. As of now, you just focus on that. We have layers. Right? Here we have 5 layers. And in host 1, we have 5 layers. In host 2, we have 5 layers. If you want to facilitate the communication between two different layers, between two layers on different hosts, if you want to facilitate the communication between two different layers on two different hosts, so then we use layer 5 we call it as a virtual communication. So this particular dotted lines indicates virtual communication, right? So that means, say for example, layer 5 and host 1 want to transmit the data to layer 5 and host 2, right? That particular communication is being done with the help of this particular layer 5 protocol. That means each and every layer will have a protocol according to the layer name, layer number. So for example, as we have been facilitating the communication between the layer 5, we have layer 5 protocol. So layer 5 protocol specifies some set of rules and regulations. With the help of that particular rules and regulations, layer 5 and host 1 will establish a virtual communication with the layer 5 and host 2. Layer 5 and host 1 and layer 5 and host 2 are called as peer layers. We call it as a peer layers. That means if they have been on the same level in two different hosts, we call them as a peer layers. So that is virtual communication. If you want to transmit the data within a particular host from one layer to another layer, that we call it as an actual communication. For example, layer 5 in host 1 wants to transmit the data to layer 4 in host 1 only. So that will be done with the help of the actual communication, and the actual communication is being done with the help of layer 4 by 5 interface. This particular layer 5 will have layer 4 by 5 interface. This particular interface is responsible to transmit the data from layer 5 to layer 4 with the help of the actual communication. In the same way, if layer 4 wants to transmit the data to layer 3, here we have layer 4 by 5 interface, layer 3 by 4 interface, layer 3 to layer 2, we have layer 2 by 3 interface, And from layer to layer 2 to layer 1, we have layer 1 by 2 interface. In the same way, here also, right? Both the hosts have been connected to the physical medium, which is responsible for transmission of the data in the form of zeros and ones. In the form of zeros and ones, so both the hosts have been connected to this particular physical medium. This physical medium, either the physical medium can be anything, right? With the help of this particular physical medium, the data will be transmitted from one host to another host. So in this particular network software, in the first topic, protocol hierarchy, we have clearly identified what is a protocol, what is an actual communication, what is a virtual communication, and what is a peer layers, and how that particular layers protocols are responsible for transmission of the data, and how interface is responsible for facilitating the communication between the different layers in the same host. All these have been discussed in this particular protocol hierarchy. That is about protocol hierarchy in the network software. In the next video, we are going to discuss about the design issues of this particular layer. I'll continue it in the next class. Thank you.